Buffer overflow is an extremely vulnerable and exploited tool used to change the flow of a program or insert code that is not supposed to be there. But from a coding perspective, it almost seems strange that such a trivial thing can introduce huge security vulnerabilities in a program. Today, we'll see exactly why you want to control your buffers, and what can happen if you fail to do so. This is important for writing secure programs, which is generally pretty important to keep your job. When you write code that takes user input and stores it in some kind of data structure, you introduce a near unlimited amount of variability in your program. Furthermore, if you write code that specifically stores data in buffers that are unbounded, you run into all sorts of problems. Say, for example, you write a piece of code that takes user input for a user's name. In such a situation, you write code that lets the user type a string as input, and you then proceed to do whatever data management you needed with that user's name. Let's say you're writing in C, and decide to store the user's name in an array of characters, as one would do in C. If you prefer a different language, just imagine you're storing the name in some kind of bounded array. Maybe you declare your array to be 100 characters in length. This seems sufficient, as there will be very few people who have a name longer than this. So you declare your array, you get user input, and you write whatever other code you need to write. Your code is released into production, and you cash your paychecks and go on your merry way. About a week after your code is released, your company is hacked. The company's stock falls, and after a few days you get called into a meeting with your manager and suddenly you're out of a job. So what happened? As it turns out, the user input you took was a security vulnerability. When there is no boundary for the user input and it is stored in a fixed size data array, the user can write so much to the input field that they overwrite data after your array. Take this example of an array of size 10. I can input 10 characters, and then whatever else I write on top of that will overwrite the memory after the 10-character array. This can be used to wreak all sorts of havoc on your program. If the data array is stored on the stack, we can overwrite return addresses and redirect the flow of the program. Typically, return addresses are pushed onto the stack when a function is called, so that the program knows where to return to when the function is finished executing. Overwriting this can redirect the program anywhere. If the addresses of the stack are known, a malicious user can even write their own code on the stack and overwrite the return address to redirect the program to the newly added code. In some systems, clever engineers have prevented this by making it very difficult for hackers to know the locations on the stack, thus making it hard for hackers to redirect to their own code because they won't know where their added code actually is in memory. Even in the face of this challenge, hackers can get clever. Instead, they can redirect the program flow to what we refer to as gadgets. Gadgets are tiny pieces of code in the program that the developer wrote. A hacker can redirect the program control to these gadgets to accomplish specific tasks. In essence, a hacker will inject a series of addresses onto the stack, so whenever the program returns, program control goes to that address instead of the intended flow of execution. Think of this as bouncing around all over the binary file of your code, executing different instructions to achieve something malicious. The hacker doesn't inject any new code onto the stack to execute, only uses what is already there to do evil things and get you fired. There are many other ways hackers can exploit buffer overflow to attack a program, and in the face of these hacks there have also been other engineering solutions to prevent this from happening. But really, there are some much simpler and more elegant solutions than some of the complexities involved in some of the engineering solutions. The only problem is that the most simple solutions are in the hands of the developer. And to be blunt, developers often suck at this. But if you're writing code, keep in mind the following to prevent buffer overflow. 1. The language you choose can sometimes help prevent this from happening at all. In other words, don't use C and an assortment of others, but I guess if you have to, then 2. Bound your input. Simple as that. Look into the functions you're using and make sure they are ones that allow you to do so. If you do this, then users cannot overflow your buffers and cannot cause all sorts of mayhem in your memory and on the stack. And that's basically it. Keep your buffers bounded and generally you'll be okay. Thank you for watching the video. If you liked it, subscribe and maybe I'll make more. I have other work to procrastinate on, so maybe not. But if you don't, you'll never find out if I do another one of these.